All right, so these are the graphing radical functions notes. So we're going to be talking about the parent functions of the square root function and the cube root function. So just a couple of things that you may need to recall from Algebra 1. If you ever see the radical form, you have a radical sign, you have a variable inside, and you have a number in here sometimes. That is called the index or the root. A is the radicand, and then you have a power, and the power can be either in the inside or on the outside, so you can have it like this, or you may see it like this, the nth root of a to the m power. But they're both the same thing. So the m is the power, and the n is the root, also known as the index. So the parent function for the family of the square root function, so that's the first radical we're going to be talking about, the square root function, is y equals the square root of x. So here we're going to be developing the table of the square root of x. Hopefully you recall that you cannot take the square root of a negative number. So we're going to just start with 0. And if we were to plug that in here, the square root of 0 is 0. From here I try to use perfect squares because those are numbers that I actually know the square root of. So 1. If I were to use x as 1, the square root of 1 is 1. Now I don't use 2 because I don't know what the square root of 2 is. Square root of 3 I don't know, but the square root of 4 I do know. The square root of 4 is 2, and the next perfect square I know is 9, and the square root of 9 is 3. So this is my table that will help me to graph this function, the parent function. So you see we have 0, 0, 1, 1, then if we went 1, 2, 3, 4, 1, 2, there's that point right there, 4, 2. For the domain, we have a closed circle at the origin, that's where it starts, and if we move to the right, it goes towards positive infinity. So I like to use interval notation. A bracket means included, 0, comma, infinity, a parentheses because we don't know the value of infinity. For the range, we start from the bottom and move to the top, so the bottom is also a closed circle, and as you go, this line approaches positive infinity as well. So the range and the domain are the actual same. For x-intercept, that's where does this graph cross or touch the x-axis. In this case, we can see that it is at the origin, so the x-intercept is at 0, 0. And our y-intercept also is the same point. Where does it cross or touch the y-axis? And we can see that's at 0, 0 as well. All right, for the next one, we have, and before I go any further, square root of x, if I were to convert this to a rational exponent, so these are both radicals. If I wanted to convert it to a rational exponent, and we're going to get to that earlier, but I just wanted to kind of talk about this, that if we can take a and we put the power, which would be m, over the root or the index, which is n. So the square root is equivalent to x to the, well, right here there is no power, so we assume it's 1. And here, this radical sign we usually refer to as the square root, which means the inside number inside the index here is going to be a 2. So the square root of x is actually equal to x to the 1/2 power. All right, for the next one, it says the parent function for the family of the cube root function is, so this is y equals the square root of x. This one would be y equals the cube root of x. So in the index, we have a 3. If there's no number, it's understood it's the square root. Just like this one is the square root equals x to the 1/2 power. Hopefully you can make the connection that the cube root of x is equal to x to the 1/3 power. Now, the way we create this one is, instead of looking for square roots, perfect squares, we're looking for cube roots, which would be perfect cubes. So notice I have 5 here. I'm going to start with -8. -1, 0, 1, and 8. If you took the cube root of 0, that's pretty obvious, it is 0. The cube root of 1 is 1 because 1 times 1 times 1 is 1, so the cube root of 1 is 1. Now, to get the cube root of 8, what number times itself 2 more times is 8? In that case, it would be 2 times 2 times 2. So that means that the cube root of 8 is 2. Now with cube root, since it's an odd number, you can actually put negative numbers in there. It's just whatever the sign is what it's going to be. So in this case, 1 was positive, so your answer was positive. 8 is positive, so your answer is positive. For negative 1, we already know the cube root of 1 is 1, so therefore the cube root of negative 1 would be negative 1. So notice the symbol doesn't change. We know the cube root of 8 is 2, so the cube root of negative 8 is negative 2. So when that index is odd, we can take the root of a negative number. If it's even, like the square root, we cannot take the root of a negative number. Now, if you notice here for the domain and range, we see that we have arrowheads going in both directions, forever and ever. So the domain here would be all real numbers, or negative infinity to positive infinity. And the range would also be negative infinity to positive infinity. And here we can see that the x and the y-intercept both going to cross at the origin, which in this case would be 0, 0. So that's the intro into the square root and the cube root function.